stickers. Come get stickers.
All right. Oh, okay. We got one more. I like the applause.
Hi everyone, my name is Daniel. I do not have stickers to offer, but I do have an opportunity for you. So I'm organizing a group of people in Portland who work in tech and are interested in using their position in tech and that vantage point to work on social justice issues. We're going to be meeting starting early next year. It's going to be about a monthly meeting series. Other facts are it's specifically for people who are young, which we're defining as 18 to 35. Not trying to be ageist, but that's a sort of prerequisite based on the sort of organization governing the process of the meetings that I'm putting together. So if any of that sounds interesting to you, please come find me at the back table by the pizza after the meeting. Thanks.
Thank you. Anyone else have anything? Or all right. So let's get out of that and then watch me fumble around with my enormous number of tabs. Not as bad as some people, but bad enough that I'm ashamed. So, all right. So we've been doing this this monthly exercise the past 2 months. Has anyone not been here for that? Oh, new blood. Awesome. It's a good thing. So basically what the Game of Life exercise is, next requisite question, who did not bring their laptop today? All right, so all of you, so keep your hands up. All of you people that have not brought your laptop, or actually, I'm sorry, let me rephrase this. All the people that have brought your laptop, look for a person who has not brought their laptop, and you will be friends, and you'll be pairing on this exercise. This exercise already encourages pairing, so it's just part and parcel to it. So, once everybody has had once everybody has selected a partner or whatnot, basically the exercise is just is to develop Conway's Game of Life. Who has not heard of Conway's Game of Life? Even more people to explain things to. This is fantastic. I love it. So, Conway's Game of Life is what's known as a cellular automata. It's not really a game so much as it is just a set of rules and an initial state. The 4 rules for Conway's Game of Life is that any cell that is currently living remains alive if it has 2 or 3 neighbors. Any cell with 3 living neighbors becomes alive in the next generation as if by reproduction. Any cell with fewer than 2 living neighbors dies as if by starvation or loneliness. It depends on how you phrase it. And any cell with more than 3 living neighbors dies as if by overpopulation. So, what is a neighbor? A neighbor in this case is anything within the 8 cells surrounding it. This is all done on a grid, an n by n grid. So basically, the cells need to know about their neighbors, and the whole exercise really is coding up these 4 different rules and then making it so that your program can iterate from one state to another state. So basically just continuing on. You can keep doing that until you see patterns form or until everything dies out or any other combination of things. It's really neat, kind of fun. There's some like emergent behaviors that end up happening, like these like glider guns that shoot little things off, and like all sorts of structures that are persistent. So it's kind of interesting. if you want, you can go ahead and take a look at the Wikipedia page, find out a little bit more about it, a little bit more in depth, probably get a better understanding of what the rules are by people who don't speak like I do, which is verbosely. So that's the general exercise. So now the next question is why we're doing this. This space, basically this exercise, is your chance to just focus on how you program things, not on an end goal. I mean, yes, we are making the game of life and what have you, but it's really about just practicing and like doing code for coding's sake rather than like trying to specifically make something. The idea is that the game of life is simple enough that you won't have to worry too heavily about what you're implementing, and you can focus on how you're implementing it instead. So it's just a place to explore. It's kind of like if you're into art or music, sketching or doing scales or practicing, whatnot. And this is just our space to just kind of have fun with programming. The other thing that this space is meant to cultivate is to cultivate best practices. And so two things are highly encouraged when doing the exercise, and that is pair programming, so that you are collaborating with someone and you're not like kind of in your own like little your own headspace. And then also TDD, and it's test-driven development. And that is partially to give you a direction, and partially to focus on how TDD might change your style of programming. So ultimately, though, this whole exercise is to work on getting us to a place where we produce good code. There's a lot of talk about good code, but really, like, what does that actually mean? Does anybody want to like throw out suggestions about what makes code good, like one line snippets about things? So, Boyana.
Code that can be changed easily, like if the developer leaves and other people take over the project.
Like, so code that is malleable. That's a good one.
Reliable, low side effects, and
So easily understood, without side effects and what have you. So like trying to reduce the number of bugs. Makes sense. I saw Sam have a hand up.
Well, it was sort of already covered, but code that when I look at it, I can understand what the hell it's doing.
Yeah, so there's this concept like that a lot of people kind of learn over time, that it's really not about writing code for computers. It's writing code that's like readable and understandable by humans first and foremost. You can optimize later, but when you're trying to change something, you need to understand what you're changing. Any other ideas about what makes code good code? Rachel.
Seems to be when you come across what culturally is defined as good code, it kind of looks nice. Like it's visually pleasing to look at.
Yeah. There's an aesthetic value that ends up happening when you write good code, yeah.
Lack of repetition.
Reduced repetition, the concept of dry, don't repeat yourself.
I was going to say a couple of things going on. Not just legible code, but following the style guide of whatever community you're in. So something that your peers can easily deal with. And less important, perhaps, is something that's efficient enough that it won't bog down your app.
Okay, so efficiency and... Oh, my brain just died.
Following convention.
Convention, yes. Following like the norms of the group that you're coding with.
Minimizing edge cases.
Minimizing edge cases. Okay. So there's one glaring thing that a lot of that no one has mentioned yet. Does anyone have an idea?
Test coverage?
There you go. Tests. Not necessarily getting at 100% test coverage, but making sure that your code does the thing that it's supposed to do. And the only way that you can actually do that is by having tests that test those business logic cases and whatnot. Go ahead, Sam.
I would argue that tests themselves do not make code good. What I was going to say is that code that works and does its job is good code, and tests are a really good tool for getting there.
Yes, tests are a great way to get to good code, and tests themselves can be bad code in and of themselves. You can have tests that don't actually test anything, but give you that 100% code coverage, and so it's important that the tests that you write actually test the things that you care about. And that's one thing that's you can have philosophical arguments about all the time. And it kind of gets to, does anyone have any other concepts of what makes good code? Okay, so we have these general rules almost. Oh God, I always forget this. It's either Michael Feathers or Martin Fowler. I think it's Martin Fowler who kind of created, like, basically specified 4 rules of good code, and that is code that has tests to test that it does the thing that it's intended, that the code is malleable and easy to change, that it doesn't repeat itself, and by not repeating itself is as small as possible. And a 4th one that I can't remember, but was covered in what we said. Let me see if I can find it. I was right. It is Martin Fowler. Reveals intention. There we go. That's the one that I can never remember that one. So, those 4 things are what he believes makes good code. So, I mentioned before that, like, this game of life practice really kind of, like, focuses on best practices. There's the whole movement of extreme programming that came out a number of years ago, thinking, like, I'm going to say, like, I don't even know. I'm not even going to throw out a number because I'm probably going to be like, oh, you're just a young person who doesn't know the origins of things. I think it was 2005, but so this concept of extreme programming basically was like a workshop that people were doing that had that people just kind of like were throwing out ideas of like how to kind of push the limits of what we do. And some of the things that came out of that were the concepts of test-driven development and pair programming. So I'm going to open up a hilarious can of worms and ask what people feel about test-driven development. Sam's laughing. Of course Sam's laughing. I hear chatter back there. Clearly you have something to say.
I was going to say it can get annoying, but it's also very helpful for, like, especially getting the small building blocks and then continuously going from there.
So, go ahead.
I find it really helpful because I'm like a verbal learner, so I actually think when I'm talking.
Mhm.
So like I'm building a Ruby REST API with a friend, and we're talking about like all the different verbs we want to use and all the different methods, and it really helps just like order our chaos of our minds
Mhm.
to do it. I don't know if we do it in perfect R spec, but we just do it in like pseudocode, and it helps us a lot.
So, hitting off on that concept that like it can be really annoying. Why is it annoying sometimes?
Just because you see this problem and you kind of want to go all in on it, but then you're kind of forced to take a step back and kind of remove yourself and then take it slowly compared to, oh, then I can do this, then I can do that, then I can do this, which can result in you getting lost, so that's why it's...
You
That was pretty much my point, was you can see the solution and get to the solution faster than you can with tests or what. And it's annoying to have to sit back. I'm working on a problem where it's taking me longer to write the test than to actually get the solution.
why is it taking longer to write the tests?
I'm having to learn a lot about like, the testing framework.
Okay.
There's a lot of my own personal learning.
Mm-hmm. Back there.
It forces you to really think about what your goal is rather than what you can bang out.
Mm. So how many people have just come into a code base that has poor test coverage or is like poorly tested and tried to do TDD there? What are your experiences with that? Does anyone have any? Rachel?
Well, I wanted to expand upon the last point.
Okay.
From the viewpoint of a newer or more junior developer, when there is a good test suite in a place that you're stepping into, you kind of have a bit of security while you're working to know that while you're trying to really figure things out, that you haven't broken everything. And it can be a real helpful, I mean to everybody, but especially like if you're new, a real sort of like booster.
Yeah, no, that makes sense. Like just having that security, like that's one of the reasons why, like in the whole concept of the red, green refactor cycle, like if you don't have tests that actually test what you're changing, then you're not refactoring. You're just moving code around and maybe shooting yourself in the foot. And so, like to that end, I'm actually curious about this. How many people, before they change something, when they're not sure about the test coverage, how many people intentionally break what they're doing in order to see if there's actually any tests that fail? You should really start doing that. If you have a test suite, make sure that if there's an if statement that you're like, I need to change this if statement, try just like changing it to like the opposite. Just put a not in there. See what happens. See if any test breaks. Because if no test breaks, then guess what your first job is? Write a test for that.
Or raise an exception.
Or raise an exception. Make it somebody else's problem. Yes, that's another good one. But making sure that you have something that tests what you're changing is imperative to really do that, to do the red-green refactor cycle. Because if you're just changing something and all the tests are passing, then do you know that if your like new test is actually covering the same thing, or are you basing it off of something that also wasn't already like testing what you're changing? So it's really important to make sure that you have that baseline, that you have that safety net. But speaking of that like really poor safety net, how many people have spent like literal like hours trying to figure out how, like what dependencies they're missing inside of a test, and just being like, I don't want to write this freaking test because it just breaks for some reason that's completely unrelated to what I'm actually testing, and because I do that all the time. There's not enough people laughing about that. That makes me sad and feels like my life is terrible.
It happens to me all the time. I feel embarrassed about it.
Okay, yeah.
Learning.
One of the things that I feel that I personally feel that TDD actually does is that it teaches you about those dependencies. When your tests take a while to write, when you struggle with that, like that issue of setting up the tests and of like have those like setup blocks in your RSpec code of like 30-40 lines long, that's a huge warning flag that you need to do some major refactoring there. Tests should not take hours to figure out to write. It should literally just be, oh, I just need this, and then I modify this, and I get this result. Like it should be like adding 3 new lines of code, and then you've got the test case covered. So those moments when you have to add like 10, 20 new lines to get a new test case, that's a pain point. You should listen to those pain points. So, who has other thoughts on TDD? Go ahead.
I'm still a little bit new to it. like that it's making me think about kind of the data structure of my app before I even start writing functions or I start writing classes. I'm thinking about what's coming in, what's going out.
Mm-hmm. Yeah, that's kind of the concept of like when you're writing tests for code that hasn't been written yet, like when you write that first test, you're writing the code that you want to write. You're setting an expectation for yourself. You're not confined by anything, so you can really shape it by placing those initial constraints. That's really kind of one of the beautiful things about it. And then as you continue developing it, when you start feeling those pain points, when you start having to go back and like change like 5 or 6 tests, that's another warning sign to like step back and be like, what am I missing here? Just take that moment and like think about what could be done differently to alleviate that pain. Who else has? Oh.
I think like tests declare your code's intention, right? They're part of the documentation. If you have a test around a piece of code and it says this is how I expect the code to behave, and the code behaves that way, then you know the code is like kind of working the way the developer intended it to work. If you have a piece of code that doesn't have a test, there's no way to know if the code is behaving the way they think it should behave or want it to behave, or if it's just a bug that somebody else has worked around. And so like the test makes your code, like it's one of those rules, right? The test makes your code declare its intentions.
Mm-hmm. So, go ahead.
It's a bit like consensus. Somebody sets an intention. If anyone wants to break that, they have to intentionally break that. So it's like a hive mind set this goal, and you have to think twice about why somebody put that guard up. I don't know how to better describe it.
Yeah. Who here has encountered the thing where you try to change one thing and like 6 tests unrelated to it break? I see a very exasperated hand up back there. Bad tests are freaking nightmares, in my opinion. A test, like a test suite that tests implementation rather than the business logic is a nightmare. Does anyone have words on like what does it mean to test an implementation?
Is that like behavior-driven development or like functional?
So behavior-driven development should specifically like be like I want this behavior to happen, and then you're testing to make sure that behavior happens. So it is an interesting thing to talk about, and it's kind of like the higher level like zoomed out view of TDD almost, behavior-driven development. So back there.
Isn't TDD the formalized version of rubber duck programming?
In a lot of ways, yeah, it can be. It is you talking to someone and recording that conversation, saying this is what I want it to do. Now I have to go do it. It is kind of that concept, but like again, rubber ducking. So rubber ducking is when you're trying to figure out a problem and you just can't seem to figure it out, and you literally just turn to something on your desk, whether it's a rubber duck or anything else. You can theoretically do this with an actual person who will talk to you, but that person can just. Yes, usually you do this beforehand to make sure that you're not, like, quote unquote, wasting the time.
Well, sometimes you just speak it out.
Yeah. So it's just like turning to like the thing on your desk and being like, pixelated Pokemon on my desk. Why does this actually do this? I really want it to do this, and it's doing this instead. And I think it should just be doing this. And as you're trying to like frame it into words in a conversation, sometimes you have that like light bulb moment of like, oh, that's what I'm forgetting because I glossed over it. It's like being told, like telling somebody how to make a peanut butter and jelly sandwich and then not telling them to like open up the jars. And the person's just like, I can't get it. What's going on? So it's a way to uncover that. And so like TDD in a lot of ways is kind of like telling your computer, like having that dialogue with your computer and kind of opening that up. But again, getting back to like the concept of like testing implementation, like rather than behavior or rather than output or business rules. Sam?
This is where a lot of people run into trouble with mocks and eventually conclude that they hate mocks. Because mocks are a really good way of testing a small, polite object that interacts with a few well-defined collaborators. You can say, when I poke this thing in this way, it pokes its neighbor in that way. But the way a lot of people use mocks is to just like step out about a bunch of shit they don't want to deal with, and you wind up with code that like mocks 10 things and stuff to 5 others. And as soon as any of those implementations break, so do all of the tests that relied on that behavior.
Sorry, what was that?
I was just saying, like, earlier I mentioned that knowing good code is knowing what's going to happen at the end. Like, so minimizing side effects. So, I don't know if I'm correct, I'm assuming that what you were saying with mocks tends to have, like, potentially more side effects, or it's not pure functional programming.
Side effects are sort of related, but they're not really primary to mocks. Mocks are they're partly a design tool and partly a tool for making your tests faster by isolating the thing that you're actually testing by replacing it with like nothing objects. But mocks are really intended to be used at the boundaries of an object, whereas a lot of the mocking and stuff that I see in the wild is concerned with internal behavior of an object because that object is human.
I've heard a lot of argument against mocks. Anybody want to talk to that? I would love to hear from
Oh man, that is
Someone has something to say about that.
that is an enormous can of worms and can be talked about like ad infinitum. Honestly, if you have opinions about that, there's this meetup that I know about that would love to hear talks about this type of thing. And I think it's called Pdx.rb. You should probably talk to Rachel back there about your desire to have this conversation. But yeah, so Sandy Metz does a really, really good series of talks that typically mention this concept.
It's kind of where I touched on it.
Yeah, but like really the concept of testing implementation really is like kind of made manifest whenever somebody like has in their tests like what is so in our spec it's like expect this method to be called like 3 times or what have you. If that's a private method and you then like no longer use that private method, that's a really freaking frustrating test failure because that didn't need to be there. It's basically saying, I want you to test that you did instruction 1, 2, and 3, but not caring about the actual result. The result is what matters, not that you did steps 1, 2, and 3. It's basically like bureaucracy in test form. And I hate it. But my own feelings aside, it's just a particularly nasty thing to worry about. So moving on, again, we could talk about TDD like forever. How many people here have actually done pair programming? How many people here have not done pair programming? Sweet Jesus, I love you all. How many people here do not like pair programming? And it's fine if you don't.
Depends on who it is.
That's a perfectly fine answer. Awesome. So I don't need to like sell you on why you should do pair that's fantastic. That said, that's kind of an amazing time for us to like pair off and actually get started on this exercise. Does anyone have any questions about the exercise? Rachel.
Okay, so I think you've already answered this,
That's fine.
but so you have the first board, right, and everything is alive or dead.
Yep, you set that board state by saying this is alive, this is alive, this is alive.
When you go to the next thing, is it a rolling thing? Each one, and it sort
You picked up on one of like the really terrible things that trips people up.
And
Fantastic.
then, like, bam, and it's flipped, but the flipped thing, the state of if I'm alive here and I should be dead in the next one, but somebody else died before me. So now I
You
am
did
I
so
dead or am I alive? Like,
that you just pointed out like one of the major trip ups of the exercise. So
awesome.
well done. It is the case that if you do it rolling, checking each one of the cells and then flip those, then you will run into the fact that like you have mutated the state of the board, and you cannot mutate it until all of the checks have been done. So you either need to hold on to its state right now and then say this is going to change in the next iteration, or you need to like do all the checks and and basically set each one. Yeah, you need to keep a state of what it is currently and what it's going to be, and then you flip a switch and make that change. Otherwise, you do run into issues. So, well done. You get so many gold stars from me right now. Any other questions? Awesome. If you have any questions, oh wait, Sam.
Do we have to finish, or in fact come up with working code at all?
No, we don't have to finish or anything. In fact, I was just about to get to like some more things about the exercise. At the end of this exercise, I expect you all to delete your code. How many people are uncomfortable with that? So, the reason why... go ahead. Is that a question?
I had one more question.
Yes.
And now I forgot it. Size of the grid.
Size of the grid.
Count for any grid size, or can we pick one?
You can just pick one. I have a standing like challenge to think about, and that's how to do an infinite by infinite grid. You do not need to do an infinite by infinite grid. If you want to, that's perfectly fine. If you want to ask me things later about how I have like conceptualized that, or just have a discussion about it, that's fine. But you can just pick a size, like be like 100 by 100, 10 by 10, whatever. Doesn't matter.
one more question, Lauren.
That's fine.
Should you feel, so is it like, can a lot of people, in the time frame of 45 minutes, should you feel bad about it if you can't do it truly TDD and finish it and it works and you've gone through the whole thing?
I will be surprised if anyone in this room actually finishes.
Awesome.
Like, I will honestly be surprised, like, if you actually can finish it and show me, like, a fully functioning version of Conway's Game of Life in 45 minutes. I've seen some people do it, but the kind of things that they do are kind of mind-blowing, and it's really bizarre. But the end goal, again, this is a space to practice programming. It is not a space to finish Conway's Game of Life and be like, I did the thing. If that's your end goal, you can do that whenever. This is literally a place to explore and to like say, I wonder if I tried doing it this weird way, what would happen? Or, hey person that I'm pairing with, how would you do it? Because I would do it this way. Let's collaborate and talk about the pros and cons of these things. That's what this space is for. It's really to explore. So, at the end of the 45 minutes, you're going to be deleting your code because, yep, so I was just about to say, the reason why you're deleting the code is because it doesn't matter. Again, the end goal is not the end product is not the goal here. It is literally just the practice of making the code. If you really, 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 really want to hold on to it, that's perfectly fine. If this is your first time doing it, that's also fine. Because there will be times when I do this exercise when I'll say you should keep your code, and those times are when I won't set really like fun/nasty programming challenges that I encourage people to do. So speaking of the fun/nasty programming challenge, if you want to really push yourself in this exercise and really try to think about it in new ways, I'd like you to try doing it without using any values returned from any methods or functions. Yeah.
Possibly accepting core libraries.
Yes. Do not. So the end goal is do not write a method, like do not physically write a method yourself that you then use the return value from. See if you can do that. It'll just kind of like force you to rethink how to do things. In Ruby, it's kind of particularly fun to think about because of the fact that like equivalency statements and whatnot are actually technically functions, and so you can't do that. But that's the accepting of the core library thing that Sam just mentioned. So, does anyone have any questions about that concept? Okay, if this is your first time doing it, you don't need to follow that restriction. It's just a guideline to push you outside of your comfort zone. So, again, if you have any questions about this, then just raise your hand and I'll come by and I will answer any questions that you have. If you want to talk through design, raise your hand and I'll come by and talk about what's going on with you. It's fine. So, find a pair. I'm going to check in 5 minutes, well, 4 minutes, and we'll see if everyone has a pair. If you do not have an environment set up, there's this lovely Pdx.rb Game of Life repo that I've set up that is in the Pdx.rb GitHub. So if you just go to github.com/pdxruby and go to the Game of Life thing, there is kind of starting places in 3 different languages. If you want to do it in Ruby, there's a Ruby one. And this will give you a starting point that has RSpec already figured out and like basically just like get you going with that. So you can clone the repo and just get a clean slate for that, for starting off. So take a couple minutes, find your pairing partner. I'll check in like 4 minutes and we will go from there. So let's get started.